Beam creation is very similar to wall creation. It requires a longitudinal axis, and two other axes, to create two insertion nodes, called the I and J node. The I end is the left end of the horizontal beam, or bottom end of a vertical beam. J is the right end of a horizontal beam, or upper end of a vertical beam. We highly recommend that you model the supporting vertical elements first, that is, column or walls, then creating beams will be very easy and error-free. Let us now look at the beam properties. B is the width of the beam. E is the offset of beam with respect to the longitudinal insertion axis. H, bottom is the depth of beam with respect to default top of slab level, which is also the top of story. H, top. If a positive value is entered, it will be an upstand. Example, if H top is 100 mm, and H bottom is 500 mm, then total depth of the beam is 600 mm. If a negative H top is entered, the beam will be lowered. Example, if H top is negative 100 mm and H bottom is 500 mm, then total depth of the beam is 400 mm. The beam analytical wireframe in elevation is always at the top of the slab, which is also the top of the story. It is not affected by the value of H top. Let us now create beams. Close the 3D view for now. Click on the beam icon in the Modeling tab, and the beam properties will appear. Let's use the default beam size of 250 mm width and 500 mm depth. To insert a beam, left-click on the first insertion node. A rubber band will appear. Click on the second node and a beam will be created. Notice that you can continue to create the beams from the previous beam continuously. Right-click to end the beam insertion, after inserting the three beams as shown. To insert a group of beams, you can draw a window enclosing the insertion points. Left-click on the upper left of the window, then left-click on the lower right of the window. Beams will automatically be inserted between columns and walls. Note that beams cannot be inserted on top of walls, as the walls are self-supporting. Continue to insert these beams. All beams created are listed in the structure tree, under Beams folder. Check that there are a total of 17 beams. Zoom into the upper left of the model, and insert a diagonal beam here. Note that we did not create the longitudinal axis for this beam. Because of this, the program automatically create this, and name it with an alias prefix. This alias axis is a hidden axis, that is, it will not be shown in the final drawing. We will now insert a curved beam, in the lower right corner of the model. Click on the curved beam insertion icon, in the Beam Properties dialog. Click on the intersection of axis A and 3 and then intersection of axis B and 4. You define the radius of the curve, by simply moving the mouse cursor, and the preview of curve beam in gray will show automatically. Press F2, to define the radius of the exactly to -1500 mm. Press Enter. A curve beam will be inserted. Note, segments nodes are automatically created. Check the structure tree that you have modeled a total of 19 beams. We will now create some secondary beams here. Deactivate the curve beam icon to change it back to straight beam. Secondary beams can easily be inserted using the Smart Snap points, without having to create axes. Place the cursor on the edge of primary beam, not the middle. Notice that snap points on 0.25 L, 0.33 L, 0.5 L, 0.67 L, 0.75 L, will be shown, when the cursor is placed on the beam. Click on 0.33 L as the start point of the secondary beam. Place the cursor on the destination beam. Notice the same smart points will appear, when the mouse cursor is placed on the edge of the beam. Click on the same 0.33 L point and the secondary beam will be created. Let us create another secondary beam. Place the mouse cursor at the edge of the supporting beam, specifically on any of the smart point. Press F2, to manually input the exact distance, from the start of the beam. Key in 1500 mm and press Enter. Then move the mouse cursor to the edge of the next supporting beam. Notice a perpendicular point is shown. Click on this point and the beam will be created. Check the structure tree that a total of 21 beams are created. Let us now explore the other parameters of the beam. Under Type, there are two other options other than the default. A support band beam is a dummy beam used in flat slab system, which usually requires the model to run the FE floor analysis. It will have the same depth as the flat slab. Wall coupling beam is used effectively to combine two shear walls, that are used for withstanding large lateral loads, specifically seismic loads in accordance with the selected seismic code. End release. Beam ends are fixed by default. You can apply hinges to left and or right by clicking successively on this icon. To explore the next parameter, create a 3D view. Drag the window to maximize the 3D view. Then zoom into this secondary beam in 3D view. Select this beam, right-click, Properties. Go to the 3D tab. The plane fields will be populated if a plane element is created and used to adjust the beam elevation positions. Del Z, INJ controls the elevation position of the start and end of the beam. This directly affects the analytical wireframe position of the beam. By default, delta Z equals 0 means that start and end nodes coincides with the top of the story. If you key in positive value, it means you are raising the node position. Try entering 1000 mm for del Z, I, and update. Examine the 3D view. Conversely, if negative value is inserted, the beam node is lowered. Try entering -1000 mm and update. Examine the 3D view. Be very careful when using delta Z adjustment, as the beam may be unsupported if an erroneous value is entered. For simplicity and to avoid unsupported elements, we recommend you use the H-top property of the beam instead, for small adjustment to the elevation of the beam. Go back to the 3D tab and enter 0 vales for del Z. Update. Then close the beam property. Go to Views tab. Click Reset to restore the view's arrangement. Let us now proceed to model some cantilever beams. Go to the Plan view. Zoom to the upper right corner. Select Axis 4, right-click, Offset Axis, and click 2 meters away, that is 2 grid box away. Click on the beam icon. Create a beam here. Notice the red triangle will appear, which is a cantilever marking. It means the right end is the unsupported. The arrow points to the direction of support. The cantilever marking will affect the design of the beam, as well as its detailing. For example, in the design deflection check, this beam will be checked as a cantilever. In the drawings, the beam will also be detailed as cantilever. The cantilever marking can be changed if desired. With this beam selected, right-click, choose Mark Free End of Cantilever Beam. 3 options are available. Both end supports means to remove the cantilever marking. I end free will mark the left node as cantilever, while J end free will mark the right node as cantilever. Create another cantilever beam and then another beam joining them. Close the beam property. You can adjust the position or eccentricity of a beam by simply selecting it and then pressing keyboard arrow keys to move in the direction you want. The step by which the member is moved can be set in the Settings Center. Under View and Save, Member Section Eccentricity Step. By default it is 25 mm. Select this beam and press the left keyboard key, so the beam right edge is aligned with the axis. Note, you can also move columns and walls this way. Let us delete the last 3 beams we have created. Select these beams using any method. Right-click Delete and choose to delete beams only. Save the model.